Okay, good morning. Let's work through the review for solving quadratics. So number one, we have find the solutions to the quadratic function h of x equals x squared minus 49. Remember, when we say solutions, we're talking about the roots, we're talking about the zeros, we're talking about the x-intercepts. Now we have x squared minus 49. Since we're looking for the zeros, we're going to set this equal to 0. Now, this is a difference of squares. So we can do it by difference of squares. We take the square root of x squared plus the square root of 49 minus the square root of 49 equals 0. So we have x equals -7, x equals 7. We could do it this way. We could do this using the quadratic formula. We could do this by graphing it on the calculator, putting the equation in y1, 0 in y2. We could even do this algebraically, move the 49 to the other side of the equation. You have x squared equals 49. Take the square root, and you get -7, +7. More importantly, or even easier, if you look at this, since we have a coefficient of 1 right here, what's the square root of 49? -7, +7. So without doing anything at all, you can look at this and see what the solution is going to be. All right, moving on to number 2. Number 2, find the solutions of the quadratic function 0 equals -2 x minus 18 squared minus 12. Since this is in vertex form, we cannot do the quadratic formula unless we convert it to standard form. We could do calculator, but since it's in vertex form, we can also solve it algebraically. So step 1, we move the 12 to the other side of the equation. We have 12 equals -2 x minus 18 squared. Step 2, we divide both sides by -2. So we have -6 equals x minus 18 squared. Sorry. Step 3, we square root both sides. So we have the square root of -6 equals x minus 18. We have a negative under our radical. This tells us we're going to have a complex solution. So we need to convert this square root of -6 to I square root of 6. Oops, I forgot my plus minus. Equals x minus 18. And then our last step is to bring the 18 over by adding it to both sides. And we end up with x equals 18 plus minus I square root of 6. Now we could leave it like this, or we could take the square root of 6. Calculator turn on. .45. So we could have x equals 18 plus or minus 2.45 I. Now, this tells us that if we were to try to do this on the calculator, we would get a parabola that does not cross the x-axis. And so we would have to use either the algebraic we just did or the quadratic formula to find the solutions. All right, number 3. What are the two non-real roots of the quadratic equation? X squared equals, or h of x equals x squared plus 6x plus 13. Here we're already in standard form. And since it's telling us non-real roots, we cannot use the calculator. graph. We could use the calculator for the quadratic formula, however. So straightforward, our A equals 1, our B equals 6, our C equals 13. So we have -6 plus or minus the square root of 6 squared, which is 36, minus 4 times 1 times 13, which is 104. All of that over 2 times 1, or 2. So if we go to our handy-dandy calculator here in a second, let's go ahead and simplify this a little more. X equals -6 plus minus the square root of 104 minus 36. So that's 68. That's -68. So if we go to our calculator, now remember, do not do this in fraction form because it's an imaginary result or complex result, and you will get an error message if you do this in fraction form. So you need to put this in the calculator like this. You go parentheses, -6 plus the square root of -68, parentheses, divided by 2. And be careful, because I know from yesterday, a lot of y'all were going fast and making some errors in putting it in the calculator. And so we get x equals -3 plus minus 4.12i. Now, if your answer is in fraction form, where just the radical has been simplified, you can just put the answers in the calculator and see which one gives you the decimal result that you need. All right. Number 4, solve the following quadratic equation, identify all the roots. So we have f of x equals 5x squared minus 6x plus 1. I'm going to walk you through the steps for the calculator. So y1, we're going to put 5x squared minus 6x plus 1. y2, we're simply going to put 0. So 5x squared minus 6x plus 1, 0. Graph. And we get our parabola. Now we go second, trace, 5 for intersect. Remember, we're going to do this twice. So second trace, intersect. The first time we could just hit enter 3 times. And our first x is x equals 0.2. We do it again, second trace, 5. This second time, we need to move the cursor to the second intersection. And we get x equals 1. Why is that 0.2 now? Right. Okay. And we can double check. Anytime you get an answer that you don't think makes sense, you can always just plug it in. So 5 times 0.2 squared minus 6 times 0.2 plus 1, and we get 0, so that is the correct answer. Easy way to double check your work. All right, number 5. Solutions to the quadratic x times x minus 10 equals -20. We could do this graphically. We could do this, so on the calculator, we could distribute this x to create a quadratic expression in standard form and use quadratic formula, but we have an already factored quadratic equation. There's no reason to do any of that. What we have to do using our zero product property is find the two values that make the equation equal to 0. So we have x equals back up. Sorry. So we have x times x minus 10 equals negative 20. And I did mess up on this. Since it's not set equal to 0, we do need to do something with this one. So we are going to go ahead and distribute. So x squared minus 10x plus 20 equals 0. Now from here, you can do the calculator, you could do the quadratic formula, and those are really your two options. So quadratic formula, we have positive 10, because remember, reverse the sign on that first b, plus or minus the square root of, or the negative 10 squared, which is 100, minus 4 times 20, so 80 times 1, so minus 80. And all of that is over 2 times 1, or 2. So we have 5 plus or minus the square root of 20 over 2. And if we wanted to, we could check to see if it's if the answer's in a fraction form, we're good here. Otherwise, we could go ahead and take the square root of 20 divided by 2. So we have 5 plus or minus 2.24, or x equals 7.24, and x equals 2.76. And there's your solutions. All right, number 6, quadratic equation. 3x squared minus 12 equals negative 5x. Which of the following are true? So we've got the vertex form, we've got the axis of symmetry, and we have the range is equal to negative infinity to negative 169 over 12. Fair enough. All right. So to convert from quadratic, so for standard form, so let's go ahead and set this equal to 0. We have 3x squared plus 5x minus 12 equals 0. Since we're going to vertex form, instead of solving, we're going to use a cheat code. We could do this by completing the square, or we could simply observe that h is equal to negative b over 2a, or h is equal to negative 5 over 6. So that's our h value of our vertex. Remembering our form is y equals a x minus h plus k. So if we look right here, this is telling us h is negative 5, 6, which means our axis of symmetry is indeed x equals negative 5, 6. So to find our k value, what we can do is we can simply substitute or plug in our negative 5, 6 into our original standard form right here and see what we get. And I'm just going to do this on the calculator. And here you can use your fraction form. So 3 times alpha y equals, bring up your fraction template. negative 5/6 squared plus 5, oops, not times, plus 5 times alpha y equals negative 5/6 minus 12, and we get negative 169/12 for k. So if we look at our vertex form here, our a value comes straight across as our 3, x minus h, so flip the sign, negative 5/6 becomes plus 5/6, that's good. Minus or plus k is a negative 169/12, this is negative 169/12, correct. So all we have left is our range from negative infinity to infinity. Now if we look down here, we can eliminate this answer, we can eliminate this answer, because we know 1's involved. Range is negative infinity to negative 169/12. So if we look at this, this is an upward facing parabola since our 3 is positive, meaning our vertex is our minimum. Therefore, the range for our parabola, our quadratic, is going to be negative 169/12 to infinity. Therefore, this is not one of our answers. And so therefore, it must be B. Number 7. Find the roots of the following quadratic using quadratic formula. Straightforward. So we identify our pieces. A equals 5, B equals 10, C equals 4. So our quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So this becomes negative 10 plus or minus the square root. 10 squared is 100. 5 times 4 is 20, times 4 is 80. And all of this is over 5 times 2, or 10. So then we have negative 10 plus or minus the square root of 20 over 10. Negative 1 plus or minus the square root of 20 over 10. So we can go negative 1 plus the square root of 20 divided by 10, negative 0.553, negative 1 minus the square root of 20 divided by 10, negative 1.447. And there we go. Could you double check this by graphing and make sure you did your work correctly? Yes, you could. Okay, pause there for a second. All right, let's take a look at the next page. All right, Bob wants to calculate the amount of time it takes for a shoe to fall from the top of a 40-foot tree to the bottom of a well 20 feet deep, located next to the tree. The height of the shoe can be represented by the function height in terms of time equals negative 16t squared plus 40, where h is the height and t is the time in seconds. So our first question, how long does it reach height? How long does it take the shoe to reach height of 20 feet? we're simply going to set our equation equal, since this is height in terms of time, and we're solving for time, 20 equals negative 16t squared plus 40. Now, we have some tricks that we can do, and I'll explain this in a second, but we're going to set up each one of our questions. How long does it take our shoe to reach the top of the well? Top of the well is at the ground level. So if we draw a picture, we have our tree, we have our well. Our tree is 40 feet, our well is 20 feet. Ground level, as far as we're concerned, is 0. So shoe is dropping. How long does it reach the top of the well? We're going to set this equal to 0 because the top of the well is at ground level. And then how long does it reach the bottom of the well? Since the bottom of the well is 20 feet below ground level, negative 20. Now, you don't have to solve all these equations. Our function is the same for all of them. So if we go negative 16x squared in y1 plus 40, clear, negative 16x squared plus 40. So we put that into y1. In y2, for the first one, we're just going to put 20. We're going to hit graph. You're not going to see your equation because y2 is 20. So we need to go to window. We need to change our y max to 25. And let's go ahead and change our y min to negative 25. That'll save us from having to do it in a minute. We hit graph again. There's our line. Where is my parabola? Let's go back to window. Let's change our x to negative 1, and our max to 5. Graph again. There we go. Barely see the parabola. The parabola is like flying. So second trace, intersect, enter. What did I do wrong? Oh, yeah, that would be a problem. I did times 40 instead of minus 40, or plus 40. Graph. There's my parabola. And there's my line, y equals 20. So here, since we have our squared, we would end up with 2 square roots, one positive, one negative. Again, we're dealing with time. We don't care about the negative. So we're going to go to second trace, 5. We're going to bring our there it is. Bring our cursor over to the second intersection. We're just going to hit enter 3 times. And so this one is time equals 1.12 seconds. We go back to y equals. We go to y2, and now we change it to 0 for our second equation. Our parabola again. We go second trace, intersect, enter, and we get time equals 1.58. And then for our last one, we go back to y equals again, go to y2, and we set it to negative 20 for the bottom of the well. The graph. We have our parabola, we have our line, y equals negative 20. And this is why I set the y min to negative 25 a minute ago. So we can see that negative 20 line. So second trace, 5, enter. and we have 1.94 seconds. So you don't have to solve each one of these equations individually. We just put our function, our quadratic in to y1, and we put each of these into y2 separately to find our intersections. And we're going to do the same thing for number 9. Following function describes the path of a golf ball. H of t, so height in terms of time, equals negative 16t squared plus 72. After how many seconds will the ball reach a height of 48 feet? We're going to set it equal to 48. Now, we have a difference of squares. We could use quadratic formula. We could use graphing. We could even do this one algebraically. So let's take our 72 over to the other side. We'll subtract 72 from both sides. You get 26. See, even every once in a while, gotta check your work. 24. 24. So we have negative 24 equals negative 16t squared. Divide both sides by negative 16. And we have negative positive 1.5 equals t squared. We take the square root of 1.5, and we have t equals, normally it'd be plus or minus, but we don't care about the minus, 1.225 seconds. And you can see how many decimal places the answers are to figure out how many decimal places you need to go. Number 10, solve the following quadratic inequality. So we have x squared plus 2x minus 12 less than or equal to 3. We could do quadratic formula, set our inequality to 0. We could graph it in the calculator as is with y1 and y2. Again, it's whichever one is easier for you to remember and be able to apply. So we're going to do calculator again. So x squared plus 2x minus 12. Get rid of this. Two x squared plus 2x minus 12. And then in y2, we're simply going to put 3. Hit graph. Okay. Oh, I need to go back and reset my window. I have a window for -1 for y min. So our x min, I need to go back and set that to -10. X max back to 10. And there we go. So you should see your parabola is going to look something like this. And then you have a little line come across at 3. So you're going to find your two intersections. You're going to find your two roots just like you would in a quadratic equation. So second trace 5, enter, enter, enter for the first one. And we have x equals 3. And then we're going to go second trace 5, move the cursor to the other intersection. Enter, enter, enter. -5. X equals -5. Okay, so these are our 2 points. But since this is an inequality, we're looking for an interval. Now, visually, you can do this by going, since this is less than or equal to 3, we're looking for the parts of the parabola that are below our line. And that would be this part of the parabola right here. Therefore, any value of x between 3 and -5 will satisfy our inequality. So we can write this as, and since it's less than or equal to, bracket, -5, comma 3. We could do -5 less than or equal to x less than or equal to 3, or we could do our number line, -5, 3, closed circle, shade in between. So any one of these will work. And you should be able to recognize any one of the 3. So now solution set for quadratic inequality, same thing again. We're going to go back to y1, clear it. We have x squared minus 15, and then -7x in y2. We're going to hit graph again. We'll see our parabola, see our line. Now the top of the second intersection on the left is above our window. So let's go ahead and change our window, change our y max to 35. Go back to graph. Still can't see it. Almost there. Window, let's change our y max to 60. We'll get the little bugger. Window 75. There we go. Second trace, intersect, enter. So our first intersection is at x equals 1.72. And x equals -8.72. Now, we end up with a parabola that looks kind of like this. And then it has a line that's going like this-ish. Now, inequality is saying greater than. Therefore, we're looking for the pieces of our parabola that are above. So our intervals are going to be outside our points. And if you didn't realize this, you could plug in a 0. And we have 0 minus 15 greater than or equal to 0. So is -15 greater than or equal to 0? No, false. So it's got to be the outside intervals. So for inequality, and since it's equal to, again, we're going to use braces or brackets. So -infinity with a parentheses to -8.72 bracket u bracket 1.72 to infinity. And on the number line, -8.72, 1.72, closed circles again for equal to's, but this time outside. All right, we're getting there. Let's use quadratic formula for this one. We have negative x squared minus 4x plus 5 is less than 0. So our A, -1, B, -4, our C, 5. So we have 4 plus or minus the square root of -4 squared. So be very, 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 very careful. If you put this in the calculator, the parentheses go around the -4, the square is outside the parentheses. Or you can realize the fact that -4 times -4 is 16, which is 4 squared, and you can just drop the negative and square the resultant number. Minus 4 times -1 times 5, and then all of that over -2. It's -1 times 2. So we get 4 plus minus the square root of 16 plus 4 times -1 is positive 4 times 5 is 20. All that over -2. 4 plus minus the square root of 36 over -2. Or 4 plus minus 6 over -2. So 4 plus 6 is 10, divided by -2, -5. 4 minus 6 is -2, divided by -2, 1. Those are our endpoints. So if we check 0, 0, 0, plus 5 greater than 0 or less than 0, false. So it's outside. So again, we would have negative infinity, and since this is only a less than, we're going to use parentheses. It's a -5, u1 to infinity. All right, number 13. Online music service sells downloads. Profit function is our P. Profit in terms of downloads is equal to -5d squared plus 450d minus 1,000. How many downloads they need to sell to make a profit of more than 6,000. This should look very familiar, as in it was on the work yesterday. So since we need more than 6,000, we're going to have 6,000 as our profit is less than, whoops, not less than or equal to, just less than. Because since this says more than 6,000 is not a viable solution. -5d squared plus 450d minus 1,000. And so doing this on the calculator, sorry, we go to y equals. Clear our stuff out of y1 and y2. And we have -5x squared, again, plus 450x minus 1,000, and then y2, 6,000. Now, because y2 is 6,000, we need to go immediately to window, and we're going to set our y max to, say, 6,200, so we can see our line. We'll set x min, we'll leave it -10. X max, since we're talking about downloads, let's go ahead and set this to 100, and we'll see if we see our parabola or not. Hit graph. We can see our parabola. We don't see the top of it, but that's fine because we see where it intersects with our line. So second trace 5, enter, enter, enter. Our first intersection is at 70. So second trace 5 again. Now we're going to bring this back over enter, 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 20. Now, we're looking for, we can see graphically, we're looking for the point. So we have this, not to scale. A parabola looks like this. We have a line that looks like this. So we're looking for above greater than 6,000. So again, we're looking for this region right here. Therefore, we're looking for the interval between our two endpoints. And because it's only a less than or greater than, however you want to think about it, sign here not equal to parentheses. So parentheses 20, 70. Or number line 20, 70, open circle, shades out, up, back, shades in between. There you go. All right. Question 14, what is our discriminant? So if we remember our quadratic formula, we have negative b squared, oops, too early in the morning, plus minus the square root of b squared minus 4ac all over 2a. The red part is our discriminant. And what it tells you is the type of roots we're going to have. So if b squared minus 4ac is positive, 2 real roots. B squared minus 4ac is negative, 2 complex roots. And if b squared minus 4ac is 0, 1 real root. So we don't need to solve the entire quadratic formula. We need only look at the discriminant to tell us what type of roots we're going to have. All right, so that's the review in a nutshell.